Welcome again. Today we are continuing the lesson electric effects of electric current. Effects of electric current. In my previous video, we get some points regarding with this lesson, that is electric power, watt, electricity bill, Joule's law of heating effect, electric current, like this. Today we are going to continue. The points are solenoid, magnetic field due to current in a solenoid, force on current carrying conductor in magnetic field, Fleming's left hand rule, electric motor, uses of electric motor, electromagnetic induction, then galvanometer, Faraday's law of induction, Fleming's right hand rule, direct current, alternating current, that means DC and AC current, and electric generator. Start. These points today we learn, okay, in this video. First point, that is a solenoid. When a copper wire with a resistive coating is wound in a chain of loops like a spring, chain of loops means like a spring, then it is called a solenoid. When copper wire with the resistive coating, the copper wire with coating is wounded in a chain of loop like a spring, that atom is called as a solenoid. Then magnetic field due to current in a solenoid. Then how magnetic field is happen, that means magnetic field of lines due to current in a solenoids are similar to those of case of a bar magnet. Current carrying solenoid behaves as a bar magnet, and with it we can magnetize iron or some alloys. That means due to which what happens in our iron, the instruments or electric appliances we use in our daily use, day-to-day uses, we use iron for pressing the cloths. In that type, that means a magnetic field to current in a solenoid, that means a magnetic field of lines due to current as a solenoids are similar to those of a case of bar magnet. Current carrying solenoid should behaves like a bar magnet, and with we magnetize iron or and some alloys. Next point in this lesson, that is a force on current carrying conductor in a magnetic field. A current carrying conductor is acted upon a magnetic force when placed in the magnetic field. The magnitude of this force depends on current. The magnetic field is the length of the conductor, that means assumed to be straight, and angle between direction of the current and the field. Direction of the force depends upon direction of a current and the field. The force is maximum when the direction of the current is at right angle to the direction of the magnetic field. The force is zero when current and field have same direction or opposite direction. Okay, I repeat this point again. Just I read and I told you. Force on current carrying conductor. The conductor which carries the force, the conductor, current carrying conductor, the force on a current carrying conductor in a magnetic field. In magnetic field, a conductor which is carrying current, then what is the force on current carrying conductor in a magnetic field? A current carrying conductor is acted upon by, that means a magnetic force when placed in the magnetic field. That means when current carrying conductor is placed, force when placed, that means in a magnetic field. When in the magnetic field we placed current carrying conductor, that means it is acted upon. The magnitude of this force depends upon the current. Then magnitude of the current is depend upon current. Magnitude of this force is depend upon the current, the magnetic field, the length of the conductor, and angle between the direction of the current and the field. Okay, the direction of a force, then a direction of that force, the current carrying conductor in a magnetic field, the direction of the force depends upon direction of the force depends on a direction of the current and the field. The force is depend upon current. The force is depends upon direction of the current and the field. Force is maximum when the direction of the current is right angle. When a direction of the current is a right angle, then force is maximum to the direction of the magnetic field. The force is zero when current and field have same direction. That means when maximum when current, the force is maximum when the angle of the force is maximum when the direction of the current is right angle, and force is zero when current and field have same direction or opposite direction. Okay, that is a force on current carrying conductor in the magnetic field. Now Fleming's left hand rule. Fleming is one of the great scientists. Then he told two rules: Fleming's right hand rule, Fleming's left hand rule. Both rules for your study. Okay, the left hand thumb, index fingers and middle fingers are stretched to as to perpendicular to each other if the like this. Okay, look at here, that is a left hand fingers. Left hand finger, that is, it is a perpendicular to this is perpendicular to this. Left hand thumb, index finger and middle fingers are stretched so as to perpendicular to each other. That means this is perpendicular to this and this is perpendicular to this. Okay, if index finger is the direction of the magnetic field, index finger, that is, this is called as an index finger. The index finger, if the index finger is the direction of the magnetic field and middle finger points the direction of the current, then direction of the thumb is the direction of the force of conductor. Again I repeat it. This is thumb, this is the index finger, and this is what we say is that middle finger points. If look at here, look towards my hands. If the index of the finger, that means this index finger in the direction of the magnetic field, that means I am moving this finger, the index finger is a direction of the magnetic field, and middle finger, these are middle fingers in the direction of the current. These fingers are direction of the current, this is the direction of the magnetic field. Okay, then direction of the thumb is the direction of force on conductor. That means this is force on conductor. This is the Fleming's left hand rule. Again I repeat it. If Fleming's left hand rule, what is the Fleming left hand rule? Fleming's left hand rule says that if we stretched all fingers of left hand, the index finger means as both are, that means index finger, middle fingers and thumbs are perpendicular to each other. At that time, index finger, if index finger is the direction of the magnetic field, middle fingers are pointed to the direction of the current, then the thumb is the direction of the thumb shows direction of the force on a conductor. This shows force on conductor. That is the Fleming's left hand rule. Okay, are you get my point? Okay. Then electric motor. Next point is that electric motor, a device which converts electrical energy into mechanical energy is called an electric motor. That means electrical energy converted into mechanical energy. In previous standard or previous lessons, we get the information about electrical energy. That means energy, that is a universal law of energy. Energy we will convert. Energy never destroys. That is universal law says by Newton. Energy nor be created nor be destroyed, but one form of energy is converted into another form, that is called as the universal law of okay. Then means here when we press the button, at that time what happens, electric current, that means electrical energy converted into light energy. But in the motor what happens, electrical energy converted into mechanical energy, that is called as the electric motor. Okay, it works on the principle of a current carrying conductor placed in the magnetic field. What is the mechanism of this current carrying conductor placed, that means which principle electric motor work on, current carrying conductor placed in the magnetic field experience a force, that is a principle on which electric motor is gone. Okay, now uses of electric motor, we all know what are uses of the electric motor. The electric motor is used in the mixer, blender, refrigerator, washing machine, electric fan, tape record, hair dryer, record player, blower, electric car, rolling mill, electric crane, electric lift, electric train, computer, also pump, etc. Means you can write down in at our home, our day-to-day uses, we use electric motor for lifting the water from bottom to top on the tanki which is placed on the top of our house. That means everywhere motor is used, that means electric motor which is runs on electricity, so it is called as an electric motor. Okay, then most important points which will be most important for your 10th, 11th, 12th and future. What is electromagnetic induction? Electromagnetic induction is a very important point. What is electromagnetic induction? The process by which changing magnetic field into another device, or the process by which changing magnetic field in a conductor induces current into another conductor. That means once conductor's magnetic field, changing the magnetic field of a current conductor in a conductor. Suppose this is a conductor and change the magnetic field of this conductor into another. That is called the electromagnetic conduction. No, I repeat this again. What happens? The process by which changing magnetic field in a conductor induces a current into another conductor. Induces, this is word important, induces current into another conductor from magnetic field. I repeat it again, changing magnetic field, suppose these are two parts, the changing magnetic field of this magnetic, when current is flowing through this, magnetic field is produced, this is in this conductor. The changing magnetic field in a conductor induces current into another conductor is called electromagnetic. Current is induced into another conductor is called electromagnetic conduction. A current can be induced in a conductor either by moving in a magnetic field or by changing magnetic field, moving magnetic field or by changing magnetic field around the conductor. Electromagnetic induction was discovered by Michael Faraday in 1831. In 1831, what is that means electromagnetic induction is that suppose a current, this is two conductors, okay, in one conductor current is flowing and magnetic field is around these electric conductors, okay. The induces current into another conductor. Suppose current is flowing in this conductor, induces means introduce current into another, that is called electromagnetic induction. Then electromagnetic induction is produced in a moving magnetic field or changing magnetic field around the conductor. Move the magnetic field or change the magnetic field around the conductor, and it is discovered by the Michael Faraday in 1831 and independently by Joseph Henry in 1830. Okay, this is information about the electromagnetic induction. Then what is a galvanometer? Next point, a galvanometer is a sensitive instrument used to detect the presence of the current in the circuit. What is the current presently in the circuit which is used? Galvanometer is a very sensitive instrument used to detect present current in the circuit. In the particular, suppose one circuit is present, what is current present in that circuit? For using this, we can find out how much current is there presently. It can be used to some electrical measurements. Deflection of a pointer is usually proportional to the current. Deflection of either side of the zero mark at the center of the scale depending upon direction of the current. Galvanometer can be modified suitably to measure current in an ammeter, potential difference in a voltmeter. That means not only use of galvanometer in the checking the current presently in the circuit, it is also modifying the galvanometer we can use it as checking current in the ammeter and potential difference in the voltmeter. This is use of a galvanometer if it is modified. Okay. Then Faraday's law of induction. Whenever the number of magnetic lines of force passing through the coil changes, the current is induced in the coil. That is Faraday's law of induction. Michael Faraday, who found out the electromagnetic induction, he says that, what he says, whenever number of magnetic lines are passing through the coil, current is induced in the coil. Like this. Suppose, look at here. Suppose this is a conductor. Okay, sorry. This is north and this is south. Magnetic field of lines. Like this. Okay. Whenever number of magnetic lines of forces, these are magnetic lines of forces. Magnetic lines of forces passing through the coil changes, the current is induced in the coil. That means magnetic coils, Faraday says that whenever number of magnetic lines of forces passing through the coil, suppose this is a coil and magnetic lines of forces passing through the coil, a current is induced in the coil. They induce the current in the coil. Now next point is that Fleming's right hand rule. Just before few minutes ago, we'll get information what is the Fleming's left hand rule. Okay, Fleming's left hand rule. Similarly, another rule is that Fleming's right hand rule. Fleming's right hand rule is that stretch the thumb and index finger and middle finger. Look at my hand situation. Stretch thumb, index finger and middle fingers. Okay, all are perpendicular to each other. Then a right hand in such a way they are perpendicular to each other. In this position, thumb indicates direction of the motion. This indicates direction of the motion of a conductor. Index finger is the direction of the magnetic field and middle fingers shows direction of induced current. Again I repeat it, Fleming's right hand rule. Fleming says, what is the Fleming's right hand rule? When we stretch the right hand fingers as all are perpendicular to each other, then left thumb indicates direction of the motion. In which motion current is going, that is the direction of the motion, shows thumb. Index finger shows that direction of the magnetic field. In this way, direction of the magnetic field, and middle finger shows the direction of the induced current. That is the Fleming's left hand rule. Okay, don't be confused. Fleming's left hand rule is different and Fleming's right hand rule is different. Okay, what is Fleming's right hand rule and Fleming's left hand rule? Both are different things. Left hand rule, that means what happens? Index finger, direction of the magnetic field. Okay, direction of the magnetic field. In this also, this is the direction of the magnetic field. Index finger in both rule, Fleming's right hand, left hand. Index finger shows direction of the magnetic field. Okay, middle finger points in left hand, direction of the current. In the right hand rule, middle finger shows direction of induced current. Right hand, in the right hand, middle finger, these are three middle fingers, shows a direction of induced current. In left hand rule, direction shows, middle finger shows a direction of the current, and in the induced current. Okay, and thumb, left hand rule, what happens? In the left hand rule, thumb is direction of the force of conductor, and here thumb shows a direction of the motion. This is the difference. Direction of the current, the direction of the force of conductor. In this force of conductor, in this the thumb shows a direction of the what we say, direction of the motion. This is shows direction of the motion. It shows force of conductor. That is the difference. Same, index finger shows direction of the magnetic field. Middle point means left hand, right hand. Direction of the current, direction of induced current. And in thumb, that means in this left hand thumb shows direction of the force of conductor, and right hand side shows, indicates direction of the motion. Okay, don't get confused. What I told, again I told you, left hand rule, right hand rule. Okay, then the point is that, next point, that means direct current and alternating current. We, in short, we say DC and AC. DC means direct current and AC means alternative current. Okay, the non-oscillatory motion, non-oscillatory current that flows only in one direction, that is called as a direct current. Non-oscillatory current that flows only in one direction, called as a direct current. And current that changes magnitude and direction after equal interval of time is called alternative current. Okay, here again some missing points. That means we are get confused from this. What is a direct and what is alternating current? DC and AC, we get a confusion. What is DC? Direction in oscillatory current flow. So the current is flowing only in one direction. Current is flowing only one direction, called as a direct current. And current that changes direction and magnitude. Current changes direction and magnitude after equal interval of time is called alternating current. Okay, then electric generator, the electric device which converts mechanical energy into electrical energy. Okay, again look at the funny things. That means electric motor, electrical energy converted into mechanical energy, and electric generator, that means mechanical energy converted into electrical energy. Due to generator we get lights. Okay, that means mechanical energy converted into electrical energy is called electric generator, and electrical energy converted into mechanical energy called as the electric motor. Okay, it working based on the electromagnetic induction. A generator producing direct current is called a DC generator, and that producing an alternating current called as a AC generator. Okay, now from these lessons we get a few basic concepts. Okay, what is a current, then what are watt, then electrical Joule's law about effect of electric current, then right hand thumb rule, then magnetic field, effect of magnetic field, then solenoid, like these points, Fleming's left hand rule, Fleming's right hand rule, then electromagnetic induction, galvanometer, DC current, AC current, electric motor, uses of electric motor. These all points we learn from these lessons. Okay, I think all of you get understand it very easy way. If you have any problem, you may contact me directly. Today this lesson is finished. Thank you.